This video is on molality. Molality is a measure of concentration of a solution in terms of moles of solute in a given mass of solvent. This is different from molarity, where molarity looks at the volume of the total solution. But what's similar between the two is they both start with moles of solute that were dissolved in the solution. The formula for molality is started by the symbol of molality, which is a lowercase italicized m, which is equal to your moles of solute divided by the kilograms of the solvent. So in these, it's very important to distinguish what is being dissolved by what. The units on molality is moles per kilogram, or we can simply write the lowercase italicized m, or we can say molal. Let's do an example problem. What is the molality of a solution that contains 800 grams of aluminum sulfate in 625 grams of water? Well, first, writing my formula, I know that molality is moles of solute. In this case, my solute is my aluminum sulfate, divided by my kilograms of solvent, and in this case, my solvent is water. Most of ours will have the solvent of water. I am given 800 grams of aluminum sulfate, which I need to convert to moles. To do that, I need the molar mass of aluminum sulfate. Aluminum, there are two of them, times its molar mass of 27. Sulfur, I have 3, times its molar mass of 32. And oxygen, I have 12. 3 times 4 is 12. Times its molar mass is 16. Added up, I get a total molar mass of 342 grams per mole. So to convert my grams of aluminum sulfate into moles, I drop my units of grams of aluminum sulfate down, and I go to moles. To do this, I use my molar mass. For every 1 mole of aluminum sulfate, I have 342 grams. 80 times 1 divided by 342 gives me a mole value of 0.234 moles. So now I have my value to go here. I notice that my water is given to me in grams, and I need it in kilograms. I need to remember that there are 1,000 grams in 1 kilogram. So to convert grams to kilograms, I divide by 1,000. .625 kilograms. Now I have both of my values in the units I need. So I plug in. And I divide. When I do this, I get a molal value of 0.374 molal. Or I could write 0.374 moles per kilogram. Moving on to example problem 2. This is a more realistic problem because this is usually what happens in the lab. You're required to make a solution of a certain concentration by dissolving your grams of solute in so many grams of water. In this case, we want to make a 500 gram solution that has, or approximately 500 grams of water solution that has a concentration of 4 molal. I want to know how many grams of my aluminum sulfate must be dissolved in 500 grams of water to make my 4.0 molal solution. So looking again at my formula, molal is moles of my solute per kilogram of my solvent, in this case, water. I want to find grams of aluminum sulfate. Notice that grams are not in my formula, so I must first solve for moles. I am given my molals, and I'm given my mass of my water, which I need to convert to kilograms. So I have 4.0 molal is equal to so many moles of aluminum sulfate divided by my kilograms of water. Dividing this by 1,000 is 0.500 kilograms. To get my moles by itself, I multiply both sides by 0.500 kilograms. My kilograms canceled out, and I'm left with moles. 0.5 times 4 is 2 moles. So I know my number of moles of aluminum sulfate I need, and from here I can convert moles to grams using the molar mass of aluminum sulfate I got above. So 2 moles of aluminum sulfate, converting to grams, is a value of 684 grams aluminum sulfate. So in my 500 grams of water, I would dissolve 642 grams of aluminum sulfate to make my 4.0 molal solution.